Hello and assalamu alaikum dear students. In this video I'm going to solve Cambridge Advanced Subsidiary Level Pure Mathematics 1, and this paper is February-March 2022, paper 1-2. So in this paper and in this video I'm going to solve all the questions, and I'll try to explain it in detail, and if required I'll also explain theories associated to some of the difficult maths from this paper. So let's start. Our first question is related to integration, and it's quite simple integration. So let's start. At first, let us go through the questions. A curve with equation y equals to function of x is such that f prime x, the first derivative is given, and it is also given that function of 8 equals to 5. We have to find out function of x. So f prime x, it can also be written as dy by dx. For finding out the function of x, we have to integrate it. For finding out the value of c here, if we put the value of x as 8, the answer will be 5. So 5 equals to So let's put the value of c back in the equation, and that will be the final answer. So that's our final answer. Next, let's move on to next question. Question 2. A curve has equation x squared plus 2cx plus 4, and the straight line has equation y equals to 4x plus c, where c is a constant. Find the set of values of c for which the curve and line intersect at two distinct points. So as you can see, this is a quadratic equation and this is a straight line. So the figure will be like this. You don't have to draw it. I'm just drawing it for making you understand. So what we will do, find the set of values of c for which the curve and the line intersect at two distinct points. Let's say, for example, point A and point B. So at first we will merge the two equations. So we can write down x squared plus 2cx plus 4 equals to 4x plus c. Now we will make it in the form of quadratic equation, like ax squared plus bx plus c equals to 0. We'll convert it into that form. So x squared plus 2cx minus 4x plus 4 minus c equals to 0. Four minus c, that will be the constant. Okay. So as the line is intersecting at two different points, so that means the discriminant of the equation has to be greater than 0. When the discriminant of a quadratic equation is greater than 0, so that means we will have two distinct solutions. Okay, so if we compare it, say for example, as there is already c, so let's express the quadratic equation in different form, like px square plus qx plus r. So the discriminant q square minus 4pr, that has to be greater than 0, because two distinct solution. For two distinct solution, the discriminant has to be greater than 0. So for critical value, c equals to 0 and c equals to 3. Now look at the inequality. The inequality is greater than 0. The inequality is greater than 0, and the coefficient of c square here is constant. Positive. Coefficient of c square is positive. So that means if we try to draw the graph will look like this. So here is 0 and here is 3. So now look at here, as the inequality is greater than 0, so if we choose the value of c as less than 0, then the corresponding graph is greater than 0 or positive. And if you also consider the value of c as greater than 3, then again we are getting the value of the graph as positive or greater than 0. The corresponding inequality will be c less than 0 or c greater than 3. So that will be the final. Next question, and that's related to binomial expansion. So the previous question was related to quadratic equation chapter. Now find the term independent of x in each of the following expansion. Two expansions in given a and b, and in each case we have to find out the term independent of x. So at first, for question A, we are going to write down the general term in any expansion. So the general term is going to be, you know that, NCR. Then first term, the power will be n minus r. Then the last term, 2 divided by x square, and here the power will be r. So now what we are going to do, we are going to simplify it, and we have to keep x in a single form. So NCR 3 to the power n minus r, x to the power n minus r, 2 to the power r, and x to the power minus 2r. Because when we are going to move that x square from the denominator position to the numerator position, the power will be definitely negative. Okay, so the value of n is 6 actually. So 6CR 3 to the power 6 minus r, x to the power, we are going to combine this two term. So it's gonna be 6 minus thrice r. Now for term independent of x, that means the x related term cannot be here. So the power of x has to be 0 here, right? Otherwise we are not going to get that term. So for getting For getting the term independent of x, the power of x has to be 0. X to the power 0 is 1. So x to the power 6 minus 3r equals to x to the power 0. 6 minus 3r equals to 0. So r equals to 2. So if the value of r is 2, then this general term will be the term independent of x. So let's put back the value of r here for getting the term independent of x. So the term independent of x is 4860. So now let's move on to question B. Now here we also have to find out the term independent of x, but here we can see that with the previous expression there is another 1 minus x cubed. So we have to find out the term independent of x as a whole. Okay. So now think about it. So in the first expression, 3x plus 2 by x squared to the power 6, we have got 4860 as the term independent of x. Now, let's write down the general term here, general term of expansion of the first expression. So that 6cr, 3 to the power 6 minus r, x to the power 6 minus 3r, and 2 to the power r. Now, as already we have got 4860 as the term independent of x for this expression, and if that 4860 is multiplied by 1, then it will still remain a term independent of x. That's one thing. And another thing is, if you consider the value of r as 3, if you consider the value of r as 3, so in that case, the power of x will be minus 3. And when you are going to multiply this expression with x cubed, so the overall result will be independent of x. Okay, so let's consider r equals to 3. So 6c3, 3 to the power 3, x to the power minus 3, and 2 to the power 3, multiplied by minus x. So this term will also be a term independent of x, because x to the power minus 3 and x cubed, it's going to be cancelled out, right? So the overall result is going to be 486. So the final answer will be 54. So we are done with this question. So next move on to the next question. Next question is question 4. And it's related to arithmetic progression and geometric progression. And it's having 6 marks, so I think we have to do some more 3 to 4 steps minimum to solve the question. The first term of a geometric progression and the first term of an arithmetic progression are both equal and a. The third term of the geometric progression is equal to the second term of the arithmetic progression. So third term of the geometric progression is going to be ar square, and that is equal to second term of arithmetic progression. Second term is a plus d. The fifth term of the geometric progression, so ar to the power 4, is equal to the sixth term of the arithmetic progression. So that means a plus 5d. Okay, given that the terms are all positive and not all equal, find the sum of the first 20 terms of the arithmetic progression in terms of a. Now, if you look at the two equations, we can see that there are total 3 variables, a, r, and d. So you have to think how we can solve this. All right. So what we can do here, let me give squaring both sides of the equation 1, we will get. So it will be a square r to the power 4 and a plus d whole square. So that's equation 3. And for equation 2, so from 1, we have got this, and from 2, what we can do, we can multiply both sides with a. If we multiply both sides with a, so it's gonna be a into a plus 5t. So that's equation 4. Now look at here, left hand side of both the equation is equal. So from here, from 3 and 4, we can write down a plus t whole square equals to a into a plus 5t. Let's cancel d from all the expressions. So twice a plus d 5. So d equals to 3a. So we were able to express d in terms of a, and that's quite an advancement, because now if we want to find out the sum of the first 20 terms, so sum of the first 20 terms of the arithmetic progression, so now here d equals to 3a. But definitely in a question paper, there will be 1 or 2 questions which will require some extra thinking to solve the math. Okay, so let's move on to next question, question 5. So this question is related to completing square and at the same time transformation. That's a new syllabus, that is this topic has been incorporated in the syllabus from 2020. You are not going to find too many questions related to that, because before 2020, transformation of graph and circle geometry was not in the syllabus. Okay, so from 2020 to 2022, please try to solve all the transformation and circle geometry questions. Okay, now completing square, so that's pretty straightforward. You know how to solve it. So at first, we have to take 2 as common. You know the formula. So what's the formula? You have to divide the coefficient of x by 2. And you also have to consider the sign. If it was plus, I would write plus, but as it is minus here, so you have to write down minus. You have to write down minus. Minus, then this minus sign, it's within the formula. You always have to write down negative sign here, and whatever you are writing here, you have to write here as well and give the square sign. And this 14, the constant, it would be outside of the bracket. Yes, so 2x minus 2 whole square minus 8 plus 14. So that's the completing square form. Now let's look at the second question, 5b. The function, 2 functions are given here. F and g are defined by function of x equals to x square and g of x equals to 2x square minus 8x plus 14. Describe fully a sequence of transformation that maps the graph y equals to function of x onto the graph of y equals to gx. So how gx can be transformed from function of x, you have to write it down and making clear the order in which the transformations are applied. So if you analyze the past 4 to 5 session question paper, you will see that first you will get a completing square question, a question related to completing square form, followed by a question related to transformation. And you will see that you have to use this completing square form to explain this transformation. That 2x squared minus 8x plus 14 was given in the first question. And in completing square form, you have got that. So now think about it. So function of x. So function of x is x squared. And let's write down the g of x in completing square form that we have got in question A. So 2x minus 2 whole square plus 3. Now it will be easier for you to understand the transformation. Now look at here. At the position of x, now it's x minus 2. So that means there is a horizontal translation. If you transform function of x as function of x minus a, so that means there will be a horizontal translation plus a. Or if you translate it like this, x plus a, which can also be written as it will be horizontal translation of minus a. So the key thing here is to remember, always you have to keep this negative sign. You will keep this negative sign, then whatever you are getting here will be the horizontal translation. I mean, the amount of horizontal translation. Like say, for example, if function of x is changed to function of x plus 3, so that means it's actually x minus 3. So that means the horizontal translation will be minus 3. Okay, so look at here. At the position of x, we are getting x minus 2. So that means a horizontal translation of 2. A horizontal translation of 2. Horizontal translation by 2 unit. And this 3, it's actually vertical translation. This is vertical translation, so let me explain it a little bit. It means a vertical translation by plus 2. So that means the graph will move up. Like say, for example, if the graph is y equals to x squared, if the graph is y equals to x squared, then y equals to x squared plus 2, it's gonna be like this. So vertical translation. And if it is minus 2, so the graph will move down by 2 units. Okay, so horizontal translation by 2 units, and then again vertical translation by 3 units. Now, these two things you can read in a single line. single line, simply just translation by write it down as a matrix 2 3, so which represents horizontal translation by 2 unit and vertical translation by 3 units. So instead of writing this two line, you can write it like this, and that will cover the whole thing. Okay, fine. Now the whole transformed expression is multiplied by 2. The whole transformed equation is multiplied by 2. Now, if function of x is transformed as a into fx, so that means there will be a vertical stretch. There will be a vertical stretch by a unit. The stretch factor will be a unit. Now, as there is 2, so that means there will be a vertical stretching by a stretch factor of 2. That means, say for example, the first translation, then you will write down vertical stretch by a stretch factor of 2. Or you can also write down stretch parallel to y-axis by a stretch factor of 2. So I think you have understood. So we are done with question 5. So let's move on to the next question, which is circle geometry. First, so we can say that the equation of the circle is given and also a straight line is given. We have to find out the intersecting points, the coordinates of the intersecting points A and B. So we have to solve them simultaneously. That's pretty straightforward. So x equals to 8, x equals to 5. So put the value here, then you will get the y coordinate. So put the value of x here. Then again, x equals to 8, then y equals to 4. So let's consider this as A, and B is 5 minus 5. So it's actually, it doesn't matter because Oh, actually it matters, because be careful. A here is in first quadrant, so definitely it is 8 4, and B will be 5 minus 5 because it's in the fourth quadrant. So that's an. So from question A, we have already got the coordinates of A and B, and we need to use that these 2 points to find out the answers of question B, to solve the question B. And from the given equation, the center is -1 and 2. -1 and 2. So in question B, find an equation of the circle which has its center at C. So we have to find out equation of a new circle, and the center of that circle is C, same point, and for which the line with equation y equals to 3x minus 20 is a tangent to the circle. So now, initially, that line was a chord of the circle, the first circle that is given in the question. Now we have to find out the equation of a circle where y equals to 3x minus 20 will be a tangent. Okay, so if that is so, if you draw a perpendicular line from C to the line AB, that definitely has to be perpendicular. Why? Because now AB will be a tangent. AB will be a tangent. So from C, if we draw a perpendicular line, that's going to be the radius of the new circle. So the new circle will be something like this. Okay, so we have to find out the equation of that. Now we know the general equation of a circle is x minus a whole square plus y minus b whole square equals to r square, where a and b is the center of the circle. Now think about it. The radius will be the perpendicular line on AB, and this line, let's consider P. P will be the midpoint of AB. P will be the midpoint of AB. So let's find out P at first. So P will be 8 plus 5 divided by 2 and 4 minus 5 divided by 2. So here radius is actually PC. So we have to find out the value of the radius. Okay, so the equation is going to be, equation of the circle is going to be x plus 1 whole square minus 2 whole square, and value of r square is 155 divided by 2. So that's the equation of the circle according to the condition given in question B. Okay, so we're done here. So let's move on to the next question. So at first we have to solve a trigonometric identity. So here left hand side. So here, 2 sine squared theta plus cos squared theta. So adding this to expression, and here you can take 2 as common. Look at here, it's 5 cos squared theta minus 4. So for getting that, we're going to convert this sine squared theta into cos squared theta. So sine squared theta plus cos squared theta is 1. So 5 sine theta cos theta plus 2 minus 5 sine theta cos theta. And here minus into minus is going to be plus 2. Four divided by 5 cos squared theta minus 4. So it's done. So from A we have got From A, we have got 4 divided by 5 cos squared theta minus 4. Now, we need to solve it. So just simple equation solving. So the limit given is 0 to 180 degree. And we're getting the value of cos theta is plus minus root over 24 by 5. So at first, let's find out the basic acute angle, which is always positive, so root over 20. So I've got the basic angle. So for positive value of cos theta, there will be only one answer. That is theta equals to 11.5. Why? Because cos theta is positive in the first quadrant. It's not positive in the second quadrant. And our limit given was within 180 degree. Okay, so for positive values of cos theta, the value of theta will be only 11.5. Now let's consider the value of cos theta as negative. So within 180 degree, cos theta will be negative in the second quadrant. So the value of theta will be 180 minus 11.5369, which is 168.5. To circle geometry and integration. So the diagram shows a circle with equation. The equation of the circle is given, and the chord AB of the circle intersects the positive y-axis at A and is parallel to the x-axis. The chord is parallel to the x-axis. That's a crucial information. So we have to find out the coordinates of A and B. So that's very simple. For finding out point A, here the x coordinate is 0. So at the position of x, we will put 0. So 0 minus 2 whole square plus y square equals to 8. From here, we will get y coordinate. So y equals to 2. So that means the coordinate of A is 0. Now think about it. In the question, it's given that the chord is parallel to x-axis. So as it is parallel to x-axis, so the y-coordinate of A and B, y-coordinate of A and B is going to be the same. So here, let's consider x-coordinate as k and y-coordinate 2. So putting the value of y as 2 in the equation, we can find out the corresponding value of x. That means k. So k minus 2 whole square four. So that means coordinate B is 4, 2. So 0, 2 and 4. Let me check the answer. Okay, correct. So we have found out the coordinates of A and B. So B is 4, 2. So that's very simple. Now question B. In question B, we have to find out the volume generated by revolving the shaded segment by 360° around x-axis. To do that, in the first step, what we will do, we will find out the volume of the structure generated by the area under AB arc. So that means this whole thing, we will try to find out the volume of the structure generated by this whole arrayed shaded area. So the volume is going to be pi, lower limit will be 0, and upper limit will be 4 y squared dx. So from the equation, y squared equals to 8 minus x minus 2 whole squared dx. Now think about it. If we only rotate this unshaded rectangle here, this unshaded rectangle around the x-axis, it will form a cylinder. And the radius of that cylinder will be OA, R, and the height of that cylinder will be AB. This will be the height. So from the volume of V1, if we subtract the volume of that cylinder, then we will get the volume that is asked in question B. All right. So let's consider the volume of the cylinder is V2, and that's going to be pi r square h. So what's the radius here? Radius is actually OA. And what's the height? Height of the cylinder is going to be AB. So pi into 2 square into length of AB will be 4 minus 0. So that's 4. So 16 pi unit cube. So that's the volume of the cylinder that will be formed if you rotate this rectangle by 360° around x-axis. So from V1, if we subtract V2, then we will get the volume of the structure generated by revolving only this shaded segment, which is asked in question B. Okay, fine. So let's solve this. So the volume is going to be V1 minus V2. That will be the answer. Let me check the answer. Okay, so that's correct. So I think you have understood. So let's move on to next. This question is related to function, chapter function. So three functions are given: f of x, g of x, and h of x. In the first question, we have to solve the equation fx equals to 0, and we have to express it in SAR form. Okay, so if you look at this function, so it can be converted to a quadratic equation. How? If we consider x to the power half as a, say for example, then it will be a square minus 4a plus 1. And from here, the value of a is going to be 4. That's the value of x. Now let's move on to question B. Now here we also have to solve an equation, function of x equals to gh of x. So function of x was x minus 4x to the power half plus 1. And let me write down g of x and h of x here. Mx squared plus n x to the power half minus 2. So gh of x by equating both sides. Here, coefficient of x is 1 and coefficient of x is m. So m equals to 1. And here, the constant term is 1 and the constant term is 4m plus n. So n equals to minus 3. So m equals to 1, n equals to minus 3. So we're done with this question. It was not a difficult question, quite easy. So let's move on to circular measure. The diagram shows a circle with center A of radius 5 cm, circle with B, center B of radius 8 cm. So all informations are given. BD is the tangent at D, and ABC is a straight line. We have to find out the perimeter of the shaded region. So if you want to find out the perimeter of the shaded region, we have to add arc length CD, arc length CE, and the length of the straight line DE. Okay, so let's go step by step. At first, we need to find out these two angles. So if this is 5, this is going to be 5 as well. So in triangle ABT, sine angle A equals to perpendicular, or we can take cos A. Cos A equals to adjacent by hypotenuse. So angle A is gonna be cos inverse AD, which is 5, AB, which is 13. So let's keep the calculator in radian. .17. Right. Fine. And so angle B, we can easily find out. So angle B is gonna be pi by 2 minus 1.176. .39479. Right. Okay, fine. So now arc CD equals to r theta. The radius is 5 and angle A is 1.176. We have got arc CD and CE. Now we need to find out length of DE. So for that, what we can do here, we will use Pythagoras for triangle ABT. Fine, so the perimeter will be length of arc CD plus length of arc CE, length of the side DE. So if we add all the values here, we'll get the perimeter as 13.0 centimeter, which is the correct answer. In question B, we have to find out area of the shaded region. So for finding out the area of the shaded region, from the area of triangle ABD, we can subtract sector ADC, area of the sector ADC plus area of the sector BCE. So area of the triangle ABD, half into base into height. So base is AD. Let's consider AD as the base. So the height will be BD, which is 12. So area of the triangle minus half r squared theta for sector ADC, half into 5 square into theta was 1.176 radian. And for sector BCE, half radius is 8 square and angle is 0.395 approximately. Rad. So from here, 0.5. Let me calculate it first. There is 2.66 centimeter far. Let me check the answer. Okay, so that's the correct answer. So there is a range given in the mark scheme, 2.66 to 2.67. If you do that, you will get marks, full marks. So we're done. So let's move on to next question. That okay, so this is the last question, question 11. It is given that a curve's equation, you can say that equation, where k is a constant, find in terms of k the values of x at which there is a stationary point. So we know that for finding out stationary point, at first we need to differentiate the function. To apply the formula. And for stationary point, the value of dy by dx is going to be 0. So now all you have to do to make x as the subject. That's the value of x in terms of x. So let's move on to next question. Now in question B, you will compare this function with the function that is given in A. Both the function is same, just the difference is at the position of k here, 4 is given. At the position of k here, 4 is given, but the rest of the function is same. So this function has a stationary value at x equals to a, and this defined by, you can see that function, and the domain given is x greater than equals to 1.5. So we have to find out the value of a and determine the nature of the stationary value. Now, as I have said, that the pattern of this function and the function in A is similar, so we can use the answer from question A. From question A, the value of x was k plus minus root over k divided by 3. So here at the position of K, we can put 4. And as this number has to be greater than 3/2, so the answer is going to be 2. So that means the value of A is actually 2. Now we have to determine the nature of the stationary value. Again, both the function is similar of A and B. So that's why let's take the dy by dx from the first function. So from A, we have got dy by dx equals to minus thrice k thrice x minus k to the power minus 2 plus 3. So now at the position of k, we will consider 4. Now, as we have to find out the nature of the stationary point, we're going to double differentiate the function. Let's put the value of x as 2. We have got in B. I mean, in this question, we have found out the value of x as 2. So let's put it here. So it's going to be 9. So as d square y by dx square is greater than 0, so that means the stationary value is a minimum point. Stationary value is a minimum. So that was quite easy. So let's move on to question C. In C, a function is given and we have to determine whether it's an increasing function or decreasing function or neither. So when a function is given and you have to find out whether it is increasing or decreasing, the first thing you need to do is to differentiate it. Right here, the domain given is x greater than equals to 0. For x greater than equals to 0, 3x plus 1 whole square will also be greater than 0, and the g prime x, first derivative of function g, it's gonna be positive as well. It's gonna be greater than 0 as well. So as the first derivative is greater than 0, so therefore gx is an increasing function. Increasing function. So we're done with this question and the whole paper as well. So if you have any problem or if you have any suggestion about these videos, you can write down on the comment section. And if you want me to solve any paper related to physics or math, you can write it down there as well. I'll try to respond and I'll try to make the videos if possible. So thank you very much for the first. Assalamu alaikum.